My name's Adam. I'm with a company called PLATINA. Is that too loud? Is it good? Good? Oh, good. Okay, great. And we're kind of new kids here in the Ceph community. We've been using Ceph for about 3 years. I want to talk about a project that we built. Unfortunately, I can't name the partner that we built it with. It turns out that in sports, when you have a lot of billionaires that own their own teams, they have a lot of opinions about marketing, so it's really hard to get marketing permissions. And we gave this talk in New York for Ceph Days in New York, and they were actually with us, which was cool. But today you just get me, so my apologies. A little bit about my background. You can hold me accountable. I'm one of the people that helped start the OpenStack Foundation, and came through all those early OpenStack clouds. We built them for Walmart and AT&T and a bunch of others. And at that time, we had Swift for object storage. If you dug way down in the bottom of Swift, it was really just rsync. I don't know how many people know that today. But we built Swift-based storage systems for Walmart and others. And we were trying to build Amazon-style clouds out of AWS, so to just look, smell, walk, talk, feel just like AWS using OpenStack, which didn't make us a lot of friends at Rackspace, as you might imagine. But it was a cool mission. But the hard thing was EBS, that you just couldn't have Amazon in a box, without Elastic Block. And what came along at the time was Ceph, and Ceph was magical because it did file, it did block, it did object, and that's why, as I think Federico said, Ceph still dominates the 40 million cores that OpenStack is running on today. Like, it just cleaned the field. And Swift, and there were some guys from our startup, Cloud Scaling, that started SwiftStack. SwiftStack got bought by NVIDIA, and that was kind of the last we heard of Swift. Like, now it's just an S3 only world. So anyway, we'll talk about this project. It was pretty cool. We're pretty excited about it. So the starting point, who's touched one of these? Right, I see some smiles and some nods. It's maybe the ultimate in, scale up versus scale out, right? This is maybe the ultimate pet versus cattle. But this is where we started with our partners that, like a lot of media companies, they put everything on tape. They had the mission that, when you do live events, our data is important to all of us, but when you're holding the world championship from 1975, there is no recreating that if you lose those bits, right? There's no I'm sorry that ever gets it back. And so, we had this irreplaceable event data. It was stored in these, giant, mega refrigerators, keep one on site, one copy in, the bowels of the earth. Our partner really felt, it has historical and cultural importance. That for a sports league that's been running, for 100 years, like you really can't lose those bits without, the whole nation getting upset at you. And they considered the data the crown jewels. We live in a cloud-first world where the question is like, well, just put it on the cloud. It used to be like, can I get permission to put it on the cloud? Now it's like, what's the matter with you? Why aren't you putting it on the cloud? But they had the opinion that, this media was the crown jewels, that they just couldn't let it go. And when you have an organization that has 100 years of institutional, instincts, that they really look at it and they're like, how many vendors we've been through? I mean, this is an organization that's older than IBM, right? The only maybe tech company that's not older than is AT&T. And so they really had this feeling like, yeah, we've seen so many things come and go. That's great, but we're going to keep, the origin copy of our data. So when we sat down, we're like, oh, yeah, okay, that's great. Okay, we get it. What is it that you really, dream of? I'm an infrastructure nerd, so I don't watch a lot of sports. Does anybody here watch sports? Yeah, I mean, a couple hands. Yeah, somebody, is that a Raiders hat? Right on, I'm from Oakland. Sports has become almost like an augmented reality experience. I had to go watch some sports just to know what the heck they were talking about. But they paint the first yard line on the football field. They'll put logos on people's jerseys, like, a virtual logo. It's not even written on their jersey. It's just computer graphics added to it. The amount of data that they're collecting about sports is just exploding. In every dimension, the number of, high density, high frame rate cameras that they're putting in the stadiums and the ballpark, like that's going straight up. They're putting sensors in balls and bats and cleats and jerseys. The amount of analysis that they're doing. I mean, we're all, data junkies, so, I think baseball is maybe the ultimate, but the amount of data that they're feeding us as consumers is growing. And then it's growing in terms of betting. Like, people are applying their own ML tools to sports to figure out, okay, which guy should I bet on? They're applying it to scouting, right? If I can go get the cameras on the kids, or the college players, I can figure out who's worth how much money, and that turns into really big money down the line. And then, of course, if you can capture all the data about a game, you can now replay that game, as a virtual reality. It might be a video game, right? And so sports and video games is huge. So the game is just getting melted into data in all these different ways, and the data is being used more and more and more, and it's just going absolutely vertical. And then, of course, if you have that data, you have to do analytics on it. And so it wasn't good enough to have it in a tape archive, right? You can't access it fast enough to do anything with it, to do all these use cases that we're talking about. So we needed to have an archive, but it had to be an active archive. We really want to do the analytics on it. We wanted to federate it to the public cloud, right? Public cloud's there, so let's put a copy in it, even though we won't be beholden to the public cloud. We want to take advantage of it. And then just sort of good, enterprise IT instincts. We want to be free from lock-in, never lose a bit, right? And then ultimately, they wanted to have a better cost structure. We know at the end of the day that tape is as cheap and as deep as it comes, right? Like you want to just store it forever and not lose it and put it in a mountain, like put it on tape. And tape is still very much alive and well. An interesting fact about tape is that most of the tape that's being sold and bought today is by the hyperscales. Like 75% of the tape business is the top 7 hyperscale companies. So they've, like a lot of things in IT, they've also eaten tape, but they wanted to have a better cost structure than other things that you can imagine. They certainly were going to go out and buy, and I say this having worked at EMC, an EMC refrigerator or a giant NetApp or something. They wanted to take advantage of the way we build modern infrastructure. And so when we sat down, we're like, okay, well, what could we build it off of? And what would we pick? There was a bias towards, and we've heard this multiple times today, I want to use COTS hardware, and want to use open source software, right? For all the reasons that open source is great. It's got to go big. It's got to be validated at hundreds of petabytes. And when we're picking open source tools, the most important thing is how active is it, right? You can go to a lot of open source tools and see that, they were super cool like 3 years ago and now there's nobody there, right? So you look for a community that's alive, where there's active commits and there's experts and there's, there's juice on the mailing list. And if you ask a question, you're not gonna get a, why are you using that tool? Like, what's your problem? And so these guys, they're like, we want to go towards the bleeding edge, but it's like, am I going to bleed a pint or am I going to bleed a gallon? And these guys are very much in the let's bleed a pint, which is what you expect. Like you go out there and you touch the sharp edges and you get cut, but you don't want to be the furthest out. And and Ceph is awesome for that. You can look at it and you can say people have put hundreds of petabytes on Ceph for many, many years. And you're not going to be the first guy out there on the ice. And then all these other issues, right? Control of our data, leverage over our hardware vendors. You don't want to be, when I worked with Walmart, there was this really funny strategy slide that they had, which just had a picture of a yacht. And they said, okay, our strategy as infrastructure team is to not buy Larry Ellison any more yachts. No more yachts for Larry. So we're going to build infrastructure in that mode. Okay, so these were all the things that really led us to Ceph. When you looked at it, you're like, well, it's Ceph. Like Ceph is the answer in this use case. So, what did we, try to build? Multi-site, 40 petabytes was the initial. Not the biggest one out there, certainly not the smallest, big enough to get your attention. Really important that had a lower cost structure than public cloud. And we're a room full of people that build infrastructure, and kind of the elephant in the room constantly is, why not just public cloud? Like, why are you gonna ask me about floor loading and AB power and top of rack switch, like why? So, we posited and they believed, and it's true, that you can build it and run it at a lower cost than public cloud. And there've been a lot of high, publicity, apostates to public cloud. I think maybe Zynga was one of the first that were just like, this is awesome, but we can do it cheaper. And then, Dropbox did it. And there's been a bunch along the years that have proven that it's true. And it's absolutely true. But you wanted to match the S3 durability target. I don't know what it is. It's 11 or 12 nines. At that point, it's like, what does it matter? 50 nines, like, don't lose my bits, is what they're saying. Yeah, I won't read the rest of it. This one was important. The really small ops team. I think, I've been doing this stuff for 30 years, and it's been constantly, do more with less, do more with less, do more with less. And I think you watch, especially through the whole, DevOps rise, how many of us, sleep as many hours a night as we should, maybe not. All of us, but to be able to build it and operate it with a very small team was a requirement. Like you guys at Neuralink, right? You're like, we have a small team that does everything because we're generalists. And you can't go to your boss and go, okay, great, give me 10 more engineers. Like it doesn't, it doesn't work that way. You ask that, they're like, well, why aren't you on AWS again? You're like, All right, and then of course, wherever you have your data, it has gravity, so you have to have the compute adjacent. And this again is one of the things that the public cloud is great at. And they charge a premium for object storage because the compute is right there. It's one of the reasons. All right. So here's what we put together. I mean, very, very high level. 2 data centers, one's in New Jersey, one's in Colorado. Above it, you can see we got the tape archive on the left. There's a media manager software, which really is what adds all the metadata to and keeps track of the objects. It's the one that says, okay, here's where I want to put it, or if you want to retrieve it, you basically access it through the media manager. We ran a private network, a couple hundred gig links between the data centers, not completely devoted to Ceph, though I wish. And these are the sizes of the deployments that we put in each location. Importantly, and our partner really saw the importance in this too, is we built these sandboxes, which are just miniature version staging environments for the production environments. And if there's one thing you take away from my talk, it's like, use a sandbox, right? Like, this has saved our butts so many times. Like, nothing goes into production unless it's gone on the sandbox and been pounded on first, right? And we catch things in the sandboxes all the time. And they're not full fidelity to the production environment, but they're close enough that we can do whatever we want to. And we flagrantly do whatever we want to do on the sandbox. We just thrash them all the time because they're not just a safety net, they're an experimental pod where you can just kind of go crazy. You can see the guy in his hoodie down here. We run it from San Jose and New York and Italy. So people come in from all over the place and do the operations piece on it. Here's a rack elevation. Sorry, it's an eye chart. I'm sure when we post the talk later, you can look at this one. And this is what it'll look like when the racks are fully populated. Not fully populated yet. As I said, it was about 40 petabytes to start, and it's growing to a couple hundred. One of the things that we found, and I've heard this said by a number of people today, is once you build one of these storage systems, it becomes a little bit general purpose. Like, here's my first use case, and you're like, okay, cool, so here's my S3 endpoints. And people are like, oh, wait, you got an S3 endpoint? Can I put some stuff on it? And then, workloads they just arrive. They're like, well, I've got all these Veeam backups that could go somewhere. Can you do something with that, And so we found that the, things that are ending up on it are just growing and growing and growing. But here's roughly what it looks like. Up here, I'm not sure if anybody can read these slides or not, but at the top we have something called a cluster head. We started out our company building hardware appliances. It's has a Broadcom Trident 2 chip in there, an embedded Go system, and it acts as the Tor, but it is also is kind of a master agent for what we do inside the clusters. But pretty straightforward. Like, there's nothing magic in here. These are JBODs and 2U, 1U servers, from vanity-free hardware guys, and straight down the middle. Interestingly, if you see how much these racks weigh, each one weighs more than a Honda Fit. Back to floor loading, and each one uses more power than probably 40 small refrigerators. Like, sorry, planet Earth. Sorry to the polar bears. But yeah, it's cool. I mean, you put it together. We put a lot of network in here. Somebody was asking, is network the blocking piece? It's not blocking here. Each node has 200 gigabit NICs on it, maybe more than we needed. And the state of the project. Oh, this is more fun when it's in a PDF. More when it's in a PDF. Great. It's alive. We got it. It's up. It's working. It's running. It's out there. We've got all the sports data in it, as well as a bunch of other data that's flown in. And people are pretty stoked about it. And we're really hoping we can get the marketing approval so this can get listed as one of the Ceph success stories. I mean, I'm really happy for everybody that came out today and we're like, we use Ceph, this is our company, here's how we use it. Because, I mean, we're all part of this community, and it only will thrive if the big players that actually build cool stuff come out and say, we built it with Ceph. And so we're still hopeful to get the marketing permissions on this one. So big picture economics. Who, off the top of their head, knows how much it costs to store a petabyte of data on S3 standard for a year? I mean, there's question marks there because there's API charges and egress fee. It's about $250,000 for a petabyte per year. Google's just a little bit more, and of course, if you hit it for a lot of API calls, that number goes up. Azure's a little bit less, but it'll cost you $250K per petabyte to put it on the public cloud. And of course, building it yourself, which pieces are in there and which do I count, which not. But if you look at a TCO over 5 years and you amortize the cost of the hardware and you take the cost of the rack and you take the cost of the power and you consider the cost of your engineers that, we're not the people just accessing it above the S3 API, you really can build it cheaper and actually significantly cheaper than the public cloud. And this is something that, we've more or less proved out a number of times. And we're not the only people saying this. You can go look at the Dropbox numbers and others' numbers, and it's there. And if you have a big pile of data and you know how you want to use it, you can actually build it and run it cheaper. So, how do we put it together? I think these are some of the things that people experience with Ceph. As I started working with Ceph, one of the things that people said to me was, oh yeah, I hear that's complicated. It was almost the number one. They're like, oh yeah, it goes really big and it's really complicated. And you're like, yeah, those are some of the things. But as we built this, we found that some of the hardest parts were not actually Ceph. Even though we have a reputation for it being complex, and I've heard questions about, how do I set the defaults and, all those pieces that people wrestle with. But, building it in your own data centers, like a lot of the other things, the precursors, run a really wide gamut. The data center selection, the vendor selection, testing the different hardware. Bare metal provisioning is always awful. I don't know if anybody knows how many bare metal provisioning tools have been written over the years, but there's somebody who's put together a web page and there's like 30 different tools that have been, built. It's because that problem space is so nasty, right? Which version of UEFI are you using? And, oh, you did what BIOS setting? And so those things are just, it's a pain, right? Getting the networking right. All the systems engineering stuff, you'll spend days just, slogging through that stuff just to get to the point where you're like, okay, I just want an S3 endpoint, man. Like I can get that with a credit card in 5 minutes, over here in public cloud, or, to get to that point where the S3 endpoint is up and it's live and I can start, creating buckets and putting objects on it. Like there's a fair amount of work in there. And so I think, for us as a community, anything we can do to make that easier is really, really important, because a lot of companies come to this and it's just too daunting. Like if you're born in the cloud, like you just started in the cloud, and you're like, I know it's expensive, but I don't have these systems engineers, and I don't know how to get a data center and price it, and I don't know how to, all that stuff. Like it becomes so daunting, you're just like, oh, to heck with it, I'll just stay in the cloud. So the stack that we ended up putting together was fairly complex to handle a lot of these things. And you can see all the open source tools that you end up integrating, right? These are all, right, you guys are familiar with all of these, but you wrap them in a way to try to give this, what I want is my S3 interface way up here at the top, but where I'm starting out here is, with a lot of, paper cuts on the hardware piece, and that ultimately I need to have something that my operators can drive that, surfaces the telemetry so I know when I'm in trouble. And trying to get it into a single pane of glass or consumable CLI that people can use without being super Ceph experts, so that they can just drive the system, was a lot of the place that we did a lot of the work to get it to what we felt was production ready, operable in a way that we wouldn't lose the culturally important bits. And then, if you dig inside, you're like, well, what's really in there? It's a lot of microservices, and then a lot of orchestration around the microservices to make sure we know what the heck's going on. We put agents on all of the nodes. Of course, we use Ceph collectors. And then we built what was essentially, a machine that could query desired state and see if it actually mirrored the actual state, like you see inside Kubernetes. It's like, okay, this is what it's supposed to be, right? This is what I declare it's going to be. Is it actually that thing? And can I, actually get in there and do things that I need to do on the nodes if it's not operating in that state? But again, a lot of work just to, not Ceph work. This is not Ceph, but this is what, we thought went into making it operable, at scale. For these guys. And a lot of this was just fear-driven, right? We're like, I don't want something to go wrong and not know that it's gone wrong. I don't want something to go wrong that I could fix programmatically and then have to get up at 3 in the morning and fix it. Like, this is all to prevent us from getting shot in the head, really. So another great slide with Yoda. Thank you, you guys. The things we learn, really, like, when people say to me, oh, you're working with Ceph and Ceph is hard, I say Ceph is not the hard part. It's complex, but it's not the hard part. If you're saying, look, I've got a big load of data on the public cloud, or a big load I'm considering putting in the public cloud, and I know I can do it cheaper myself, the hard part is all these other things. It's all the systems engineering things. And if you can actually write the smarts and embed it in the system so that it can fix itself at certain times, if you can handle the trouble with telemetry and get the data out that you need so you can troubleshoot it. I mean, these are complex distributed systems, right? There's so many moving parts, like almost nobody can get their head around all of them. You're gonna be troubleshooting in real time. QA your tail off and use a sandbox. Like, it is the safety net when you fall off the high wire. And then you really can build it with better economics with public cloud if you're really willing to go for it and put the energy into it. And that's it. Do or do not. Great, that's it. I'm Adam. If you have a couple questions, I'll take them.
So what level of automation do you have around the sandbox? So if you make a change to the sandbox, it just burns everything to the ground. How easy is it for you to resurrect it and get it back up and running again?
Sorry, it's a little hard for me to hear you because the speaker's actually pointed away from me. I think you said if I burn my sandbox to the ground, was that?
Yeah, if you make some change to the sandbox, it just burns it to the ground. How easy is it for you to get your sandbox back up and running and in a clean state again?
Oh, yeah, so a lot of the software that we wrote, like we start from the bare metal provisioning, so like we can just burn it, right? Just nuke it from orbit, like it's the only safe way. You can even start with reinstalling the operating system and going from there. So that part's pretty straightforward. Like a lot of you I've heard today, we also use Ansible Chef. We're not on Ceph ADM, Ansible Ceph. And so we can rebuild the sandboxes, as many times as we want to. Yeah, and that's the upfront engineering work to have a system like this. It's kind of my point, is like that work is just as important or more important and certainly more of a pain than actually making Ceph function. Yeah. And we have regularly bricked the sandboxes. Yeah. In fact, we did it with a Ceph Ansible bug the other day. We're going to do a write-up on, so look for that. Yeah.
Thank you for the presentation.
Sure.
It's really great. So you said the cost is only half of the public cloud. So is that cost what you charge to the sports organization,
Oh, no.
or it's what you really is?
No, it's not a product fee. It's like the total in. Like, what does my rack cost me? What does it cost me to buy my hardware? What does the power in the data center cost me? What does my network cost me? What's the capitalized expense of my software engineering? Like, that whole thing, like at this scale, was literally about half the price of the public cloud. TCO over 5 years, right? Because you buy your hardware in year one. There's no getting around that, and that's a hard thing to swallow. But you can run it a lot cheaper. Yeah, I don't know what it's like at smaller scales, but at this scale, this is where the numbers penciled out.
Thank you.
Yeah.
Does that include the extra small team that you had? Because if it's in the cloud, they manage it, right?
It's everything.
Okay.
Yeah, we try to include everything. Yeah. I mean, labor costs vary, and God knows what, how aggressively you can negotiate your hardware volumes with your vendors vary. But, and please correct me, but I've never heard of anybody getting more than a 25% discount on AWS S3, no matter how big they are. Whereas, 40% discount on your hardware vendor is not uncommon. Yeah.
Can I go? Okay. So I seen that you're using per one OSD node, you're using 4 100 gigabit NICs. And are you using just a normal Ethernet or InfiniBand?
No, it's a normal Ethernet. It's not InfiniBand.
Okay.
Yeah.
And which one is like your bottleneck when you was doing like entire architecture and benchmarking the speed?
Yeah.
So which bottlenecks you hit, like in the first place?
Was
it the disks? Was it as networking? Was it
it
the
would clearly
clients?
it would clearly go faster if we changed the ratio of hard drives to NVMe, right? That would go faster. But I think it's going to be CPU in the end. Yeah.
Okay.
Yeah. But I'd be happy to follow. And this talk is normally given by my CTO.
Okay.
So
cool.
we could get way.
Oh, I'm just
way
like
deeper.
trying.
I just play one on TV. Yeah.
Okay.
So
Cool.
yeah, but we could really get into it if you wanted to.
Interesting. Okay. Thank you.
Yeah. Have you played with SI Bench? It's a new benchmarking tool from the Soft Iron guys. Danny gave a talk in Ceph Days in New York. Anyway, it's a cool new benchmarking tool. Look at SI Bench. Yeah, it's great.
What is the name once again?
SI Bench, like the letter S, I, Bench.
I'll have a look.
Yeah, new Ceph benchmarking tool. from the guys at Soft Iron. Yeah, it's great. Yeah, and I'm happy to talk in more technical detail if people want to poke and prod. Yeah. Cool. Anything else? Oh, yeah,
Thank you.
there's one more,
One more?
over here, yeah.
Yeah, so I know one of the takeaways here is that it's definitely a lot more like economical using Ceph, but I know originally you were talking about like the sports, like analytics and metrics. And did you feel like using Ceph, it kind of like, you know, gelled really well with like all the like metric analysis, or do you think there may be better options for metric analysis, but just more expensive? Or
Yeah, you know, that part's honestly still pretty nascent in this project. It's still, you know, where we're headed. And I wonder about the performance and what we're going to be able to do. It's part of the reason I was asking Sam the performance questions. But we'll see where we end up. You know, Swift Stack, when they were a thing, you know, they said, we're the high performance object store. And they got a lot of customers, and which is why NVIDIA acquired them, because all their customers were some of NVIDIA's biggest customers. And they were all doing ML on object, right? And this, you look at like MinIO. MinIO makes a lot of noise about, okay, we'll do, you know, ML and do analytics straight on top of object. And so I think it's kind of where we need to end up as an industry. We haven't quite got there on this project, but it's where I want us to be. Yeah, and it's where I want Ceph to be, which is why I think Crimson is so exciting. Yeah.
Cool.
Yeah,
Thank you.
It's a great question. Yeah. Cool. Okay. Great. Thanks, everybody.
Thank you.